Well, folks, Sean here from SMD Methods. Very welcome into this video. This is now the fifth in the series on the front wing design for formal student applications. Again, still focusing on the 2D elements of it, and at the single element, just at the main plane. Now, in the last video, I set up numerous design points, and I was looking to sweep through a number of different angles of attack for our main element. I brought it from 15 degrees, and then I brought it back maybe up to about 10 degrees, I think it was, maybe or 8, and I let it run overnight. And that was what my plan was to come back, start a new video, and then go down through all the results. Now, when I did come back to it, I was met with something similar to this. All these design points are back because I didn't save it after all these errors came in. I had numerous errors, so I literally just hit play, I stopped the video, and then I left it. I didn't come back to it, expecting again to see it completed the next day, but it didn't. And it did take a little bit of while to find out, number one, why it didn't, and then number two, what I could do to fix it so that this wouldn't happen again. So I'm going to take you through that there because it is something worth having a look at. So if you can recall, in the second video, I believe it was, when I went into mesh, one of the first things I did was I deleted off the connections, the automatic connections for this. Now, what about that? Every time I created a new design point, I moved my angle of attack. That's what the new design point was based on, a new angle of attack, and I remeshed. But every time the mesh was reinitialized or restarted, these connections were remade. And the connections there, what they did was, because this section here, this buff region, was so close here to the wall track, this wall track was reallocated as an internal region, as an interface, as opposed to a track, and I lost a boundary there, and things just went haywire after that. So there's a couple of things that we can do just to change this. Now, the first thing what we're going to do, see if you click onto the connections here folder, generate automatic connections on refresh. We just want to make sure that that is set to no before we add in a new design point. All right, so we set that into no. I can then don't have to regenerate anything here because this is a connections folder that I've updated, not the mesh folder. When I come out of this, that connection is generated. What we can now see is that when I make a new design point and we go into meshing, so for instance, let's just give that a go here together. I'm going to go into this, and I'll just write in a new design point. Tell you what I'm actually going to do. I'm going to start this here fairly low and work up, as opposed to going from 15 degrees down. I'm going to start low and go. I'm going to start from minus 12. I'm going to put that in as minus 12. Put this one in here, minus maybe 12.5. Let's keep it in for 2 for now. Right. If I cannot set this one here as such into current as of yet, I'm going to retain this data here. However, when I do go into this, I have a new angle of attack, right, at 12 degrees. It's going to say that my geometry needs updating, which it will. Right. The geometry does need updating because now I have changed my angle of attack. So therefore, the geometry is going to have to be shifted to reflect that new angle of attack, which we have in here. All this here will be updated. Okay, so let me just generate onto this. Everything's now generated. That is at a different angle of attack from where it was. If I come out of this and I now go into meshing, and we check, has a connection set been made? We should hopefully see that a connection set hasn't been made. All right, check upstream data. We should check there that a connection stream has been made. That was not what was happening in the in my last parameter sweep at the end of the other video. A connection set was being made in this. So when I connect onto this one here again, I can see that my connection set still has not been made, which is good. However, if I, for instance, had automatic connections switched on, I guarantee you, have another connection set for that gap there. That gap is set at 42 millimeters. Okay. The way I did get out of that was I lifted that gap up to 60 millimeters so that at the bottom, that track boundary was not recognized as an interface. it was recognized as a wall, and that allowed me there to enter meshing without a connection being made, such that I could right click on it and make sure that no was selected here before a connection was even made. So you need to make sure before any connections have made that the generate automatic connections on refresh is set to no, because this will be refreshed on every design point, and you do not want to generate automatic connections on this. The other thing is that we'll just make sure that the name selections have all carried through, which they have. I'm just going to generate this mesh again just to run through this. Let me pause and come back. Okay, back again. The mesh is now complete, and we can see that we've retained our buffer region. We've retained all our inflation layers to capture the boundary layer, and that buffer region is embedded very nicely into this near field region, which is embedded itself into the midfield region, which is embedded itself into the far field region. That worked out all very nicely. We can close away on out of this, and then we could solve that again in the Fluent solver. So these are the steps that I undertook at the end of the last video. I'm just redoing these again here from the perspective that I have no connections made in this. I did not send this to the Fluent setup, which I should have did. So let me just hit update for that one thing. Hit pause. Okay, back again, it's just updated. I take myself on into setup. New upstream, yes. So on this here, I haven't created any new zones as such. Well, not as such, I haven't done any new zones at all. All I did was just rotated that buffer region and the airfoil within it. I haven't changed any boundaries or anything, so I should not get any errors after changing an angle of attack coming into Fluent, saying that the mesh has identified new zones, or there's an incompatible kind of resolutions between a previous mesh and this new one, or previous zones and the new zones. We don't want that happening because we're going to be sweeping through different angles of attack. So in the background, whenever we're running this sweep through the design table, everything you're seeing being done here is happening off screen to the back to a certain extent. Mesh for display, just keeping an eye on what it's saying here on the bottom. Right, it's reading the parameters in there from the design point table, the ones that we were set to be input parameters, after having created them here in the named expressions in the previous run. All right, now it's all good, no errors. Initialization, I'll just compute that again from the inlet, and let's initialize. Done. Now run calculation. We could probably bring these down to about 600 because I was resolved, if you recall from the last video, I was resolved awfully well at 600. I didn't get any better after 600, put it that way, for this mesh. Now, that said, a grid convergence index evaluation has not been carried out on this just yet. But again, that is something that we should do for, chunks of angles of attack. Maybe not for every single one of them, but definitely an indicative angle of attack for a range of angle attacks. A GCI should be done for that. So there we go. Let's go into calculate. I just want to make sure that this kicks off. And I don't have it. I might see something here about the tangential cells with the direction of flow, which is it here, normal or not tangential, normal components. And again, that's a lot of place down there, and where we're getting the tire squish. There we go, and away on we go. So I'm going to pause this again. We'll come back after 600 or convergence, whatever happens first. Probably 600. Okay, back again. That calculation is now complete. No errors. Everything went together very nicely on that. Just in the let's just have a quick look at the velocity coming through on it. Expected. So here we'll have our squish point in here. Our separation then is coming off the lower angle well, this interaction with the front wing, obviously, and the front tire is assuming that the both lay in the same plane. So maybe sections of the wing will be coinciding with the plane of the tire to the places. But again, this is assuming an infinitely deep wing and an infinitely deep, cylinder, effectively. And what we're just simply looking at here is the cross section of that. So this is just it's really a visual interpretation of what's going on at that locations where with that sort of element that dynamic back at this flow velocity with the tire behind it might be again not taken, and this isn't taken in it washes and washes, and it's all in one of the fun things that happen in this point, this interaction that happens behind. So with that in place, let's close on out of this. See these for current and for future calculations. Come back into our table, and we'll now run the next design point. I just want to check right into the next design point before we go through the full entire suite. For the simple reason that I like just to make sure that then automatic contact regions are not being generated. Alright, so let's have a look here. So same with parameter set. Another thing I want to look at on these here. So the design point initialization. Where are we going to initialize our design points from? So when we go into Fluent and we initialize the calculation, we initialize from the inlet. So this, we have the option here that we can go from a previous updated or from a current. We go from a previous updated one, that means that it will take the flow variables, flow rate variables that we've calculated from the previous design point, apply them as the initialization variables for the next one. So it might make it a little bit more efficient, a little bit quicker, they'll converge. So in DP1, I can't just go into project, go into geometry, mesh setup solution and all. That is for DP0 still. So if I want to do it for DP1, what I'm going to do is I'm going to right click onto this one, set that as current itself. That's the current one. Now what I can do is jump into project, go on into geometry. Now I can go into geometry there if I want and refresh everything, but I'm not going to. I'm just going to refresh it from out here. And we shouldn't have any issues on this. And if we do have any issues, they'll more than likely pop out here in the meshing, and certainly in the setup. So the meshing itself, I do want to go into because I just want to validate that when I created this next design point that it didn't generate any automatic connections or any automatic contacts. So let's open up this mesh. That'll be the geometry, and normally there will say that's only a 42 mm clearance according to my tolerances, which by the way is nearly always set to slider. I think it's about 26 mm out of that, by default. There's no connections been made, which is ridiculous. Before, the way I left in the last video, there was a connection being made because I didn't have the switch off automatic connections set to automatic connections. So may as well just solve this mesh in meshing, and we'll have it open. So nothing in connection. Just say generate automatic connections and refresh. Make sure that's no before you have automatic connections made. Mesh again, let's generate this mesh. So this is at a different angle of attack. This is at a slightly steeper angle of attack at 12.5 degrees. Than the previous one at 12 degrees. So what we should also see in our table is different X and Y coordinate there for the trim and edge. Our X coordinate should be less than it was for the previous one, which means that the trim and edge should be slightly closer to the leading edge point, but it should also be higher from the track surface than where it was in the previous design point. So 25%, I'm going to pause this again, these regions in here, this is one big flow domain, one surface, and I've split the faces of the flow for different parts, whereas that part you see there is included an independent surface, which is brought and subtracted from this outer surface with the toolbar U retained. Okay, so there we are now. It's probably going to ignore that corner. Let's have a look. Again, everything still looks hunky-dory. See our boundary layer is massively close to that parabola there, but that's pretty much seeing what's going to happen. That's just how tight it's fitting. I don't want it too big, as I said, because I want to be able to maintain that gap here without having worried about this rolling down into it. And then I also wanted to leave enough space that I could get a flap for another element up here there with its own buffer region, which doesn't interfere or doesn't intersect the buffer region in this one here. Alright, so yeah, let's not make the same mistake again. Let's go to mesh and let's hit update here. Give the box of center Fluent, which it has, like that. That parabola there that I'm looking at, it probably would really harm to leave a little bit more space underneath it, which would eat into the near field discretization, which is fine because you have plenty of space there, whereas the inflation layers on the other side of the airfoil are running very close to the boundary of that buffer zone, and that buffer zone itself, of course, is meshed with its own 1mm element size independent of the boundary layer or the inflation layers. Start way up here on Fluent. I'm going to run this one here again inside in Fluent. I'll hit pause on the video, we'll look at the parameter table again and make sure everything looks okay. If everything is okay, then we'll just repeat what I did at the end of the last video. I'll stick in another few design points and I'll let that run and come back to it when it's all done, and we'll do that next video, which will have a look at that. The results of that and compare different angles of attack. So what we might do is see how far we can bring it up, maybe till it eventually causes some sort of stall. But I already know at these relatively low angles of attack, this 12 degrees is not a low angle of attack. Here we go. For this sort of angle of attack, for this sort of airfoil, it is. So let me just see what I have here. This could be indicative of a problem. There's some names. Total flow buffer region. No, that all looks okay. That's. So I'm going to hit apply here with this text just to get rid of this one. Total flow field buffer region. Fluid total flow, flow fluid total flow buffer region. That one and that one might match, but that's going to reload these. And I'll check my boundary. Make sure that there's nothing weird happening there. This is the thing where we run through a sweep. If these sort of things are coming up, we're going to get failed sweeps, we're going to get a failed study. So we'll have to spend the time to find out why this is happening and fix it. Alright, that's done. Let's have a look at the boundary conditions. Inlet buffer region. Actually, what I'm going to do is I'm going to display the meshes buffer region. Right, so that is, there's nothing there. So inlet is where it's expected to be. This is the buffer region, interior total flow field buffer region, fluid total flow field buffer region. It's the fluid zone, interior zone. That's the total flow field outlet, should be okay. And these are obviously repeats. Region 1, see what I have here. That there's the line body in the geometry, which is not necessarily required. That's going to cause trouble. We can get rid of that. We can delete that body out, which is the body operation. Let's just make sure everything else is okay. Track, full track, that big gap is here, and then run the calculation. Calculate must be initialized. So initialize there. Thought that might go automatically just on initialization even when we jumped into Fluent from the previous values, but clearly not. Anyway, same one has come up in here, which we were expecting because of that geometry between the track and the tire. We're on our way. So again, I'm going to pause this and come back once it's done, and just check and make sure everything's okay. Okay, back here again. This is now complete. There is the plot. So we're scaled down to a very, very good level of convergence. Let's just double check to make sure that nothing has come out of range, or for instance, we'll look at contours with no velocity in them. Everything seems to be okay there, which is the main check. Now I know I'm not doing any sort of big checks on what's happening here versus the last one. That's not the point of this video. It's just making sure that the design points will work from one iteration to the next. So given that the last iteration I brought up an error with the mesh zones coming into this solver, it's going to be very worthwhile just taking another design point in and double checking it. If it happens in the next one, it means that there's some other problem that I'm going to have to find out, just so I can be sure that every time I hit a design point, I don't have to go into Fluent to fix it. We will see it here. We should see it here. Differences between the design points angle attack 12 and 12.5 degrees. Tire diameter is the same. Leading edge to track distance 92.4852, 90.88. So we've come down closer to the track. By doing that, obviously we've tipped the airfoil down. The wheel out 205, right edge 42. Now our trailing edge is going up higher as expected as we've tipped it up, and it's also come slightly closer to the leading edge. So all that there makes geometric sense. Our values, we've lost values up here for one reason or another, and I expect to see that if we run another design point, we're going to lose values here as well. Why? It's because see here the solution seems to need updating. I've seen it on this one happen, and I've seen it on one other assessment that I've done once where after you run the design points, the parameter table doesn't get updated. However, when you run it from the design point table itself, everything seems to work. So let's try minus 13 degrees here. Let's see what happens. So you can see how many calculations we made there already. Clean that here. Right click, and let's set this as current, and just see what happens here. So I'm going to run the sweep one more time. Let's see what we do. Geometry, I'm going to right click that and then refresh from here. Okay, all good. Didn't take that long after all. Meshing, I'm going to come into the mesh just one more time just to check that there's no connection been made and that my track surface hasn't been converted into an internal sort of interface policy while this is starting. Okay, I just went on ahead and just generated that mesh again. I can confirm that no automatic connections have been made. The mesh is good, and I'm just going to select translation is successful. So there's the meshing on. Finally, now I'm just going to jump into Fluent. I'm going to start Fluent and just validate. I hope, fingers crossed, that when it comes in, that there isn't any trouble with the zones, as was what we'd seen in the last one. So if there isn't any trouble with the zones, I'll be happy enough to try, again, the increasing angles of attack on the design not going to execute if behind the scenes or looking at it, if there is an error. It's looking for a prompt, it's looking for direction, do something with it. Display, features, graph, everything worked okay. So it might have just had something to do with me having gone into design modeler after the first iteration. So there's no error has come up here on this one. I've gone straight into this and come on into file, coordination operations, and there's nothing to match there. Everything's good. That worked nicely. So I'm going to hit run calculation. It's going to ask me to initialize again. Okay. From the design point table, that using the previous calculation is probably particular to the design point table because it is an option that you select in the properties of the parameters box. So it may have this, it may not, obviously it has nothing inherent to do with this Fluent instance, if you like. Fluent instance is an instance where the design point table maybe is a more sweeping, overarching collection of a number of instances and the relationships between them. So let me pause this up here again and back when calculation finishes. Okay, back again, calculation complete on this one, and as normal let's just go ahead and have a look at the contour, this velocity contour again, switch all them off, and yeah, there we go. So the higher the angle of attack seems to be getting grippier here at the bottom. Maybe this because this is coming seems to be coming maybe slightly lower, even though it shouldn't. We should be maintaining 42 millimeters there. But it'll definitely maybe have something to do coming on with the curvature, but we can definitely see here along the top looks to be some sort of separation coming up here, a little bit looser. So yeah, it's going to be impossible to say just until we compare the different airfoil profiles or the different airfoil angles of attack next to each other to see actually what's going on. I just cannot remember exactly what the last ones look like compared to these, even though I do see this here seems to be merging and this kind of squish out of the tire, and this wake region here behind the airfoil's trailing edge underside seems to be a lot more joined than they were in the lower angles of attack. But nevertheless, the objective of this, as I said, is not to compare. This particular video is not to compare the angles of attack. It's really just to check out the setting up of that design point table, which I'm happy enough. It's probably good enough to go for now. Enough evidence there to see that if I do add in another 5, 6, 7 design points and hit play, that it should come through. But the proof will be in the pudding. So let's go back on into the design point table here, add in a number of additional angles of attack, and we'll add them in, making sure of course that this trailing edge doesn't exceed 250 millimeters, which is is hard set there by form student by the regulations. So in that last one, our trailing Y height went up to 165, so we have plenty of scope there to bring that up a good bit higher. So that's 13 degrees. Let's go minus 13.5, minus 14, minus 14.5, minus 15 degrees. One that would be even worth going up in full degrees is here. Go up in a full degree angle of attack. And then when I kind of get the range, you could refine that. We can go up in quarters. Say if I know between 14 and 16, I'm getting the best performance. We could maybe refine that then even more between that 14 and 16 range. Let's take it on up, minus 18, minus 19. Let's bring it all to 20 degrees and see. So there's a number of design points. I'm going to set this one up the top here again back as current. I'm going to retain all design points. So let's click this here to retain all that data so we can check them. Okay, and I'm going to update all design points from this. Right, so I'm going to finish off the video with that. And then I'll come back in the next video. We'll have a quick review of these design points, looking of course at the lift and the drag, the L over D, and maybe pulling out a couple of contours. But what I will do before I start the video is actually extract the contours to save time in the navigation to the different windows to get them out, copy, paste and all that. So your time's precious, so is mine. So yeah, thanks very much for I was again just checking an error. That's a previous error from roughly 40 minutes ago. So that was the one that we had solved. Yeah, so thanks very much for joining into the video, and I hope you pulled something out of it. I know it was kind of a mishmash throw into the middle of this video series, maybe something there that you could have looked at behind the scenes, but there's nothing worse than you or anybody trying to replicate what I'm doing or what anybody's doing or doing it in your own way. And running into some sort of head scratching error that you just can't figure out, and what's worse, you can't find anywhere anything to get you out of it. So hopefully that with that connections, automatic connections issue might get some of you out of trouble if you are trying to replicate what's being done here, or again, as I said, refine what's being done here and put your own spin on it, and maybe do it in a little bit better way. But indeed, if you do have a better way, let me know, because I'm always looking to make improvements in what I'm doing as well. But yeah, do let me know anyway. So thanks very much for joining me in the video, and look forward to doing another one, and look forward to potentially use being there with me. Thank you.